Hello, my physics students. Welcome to your very first flip video. Today we're going to be introducing some really important terms called scalars and vectors. These terms are really important because what they do is they kind of describe every single thing that we measure in physics. So in other words, every quantity we measure in physics is either a scalar or a vector. So let's talk about these a little more and learn a little bit more about them. They're really simple in some ways because scalars and vectors are different in a very clear way. Scalars only have magnitude, whereas vectors have magnitude and they also have direction. And you might be thinking to yourself, okay, Bozide, that's all good. I can see the difference between the two. That does seem pretty straightforward, but I don't really understand what the word magnitude means. So I'm going to help you with that a little bit more. Some other ways to think of the word magnitude is you can think of it as like amount, or you can think of it as like value, or you could even think of it as like size. So the word magnitude, really you can think of it as like amount, value, or size. That might help a little bit. But what will help even more is if we think about it in terms of some actual examples. So here are some quick examples for you to look at and take a very brief guess. Doesn't matter what you guess. Guess which of these you think are vectors and which you think are scalars. Great. Let's see how you did. So how about distance and displacement? Turns out distance is a scalar and displacement is a vector. So those are two important ways that we measure position or kind of length, so let's say in physics. And if we measure distance, we're measuring a scalar, only magnitude. But if we measure displacement, we're measuring a vector, magnitude and direction. So for example, let's say I start over here and I walk to the left 3 steps. 1, 2, 3. Well, what was the distance I just traveled? 3 steps. 3 steps. But what was the displacement I traveled? It was 3 steps to the left. So here you've got a pretty clear kind of example of what magnitude and direction means. So the 3 is the magnitude, but the word left is the direction. Now in physics, we're going to be doing a lot of math, and the way we represent direction with math in physics is with a positive or negative. So as you would guess, to the left is the negative direction. So instead of calling this 3 steps left, we will usually call this negative 3 steps. And that negative sign tells us the direction, that tells us to the left. What about velocity and speed? That one is easy in a way because speed starts with an S and it is a scalar. Velocity starts with a V and it is a vector. So let's say you're driving in your car. Let's say you're driving east and you're going 20 miles per hour, right? So your speed would just be 20 miles per hour. But your velocity would be 20 miles per hour east. Well, again, how would we represent that mathematically? East is to the right, so we'd probably say that's the positive direction. So we would say this is positive 20 miles per hour. There we see we've got 20 is our magnitude in all cases. Over here, east is our direction and positive is our direction. Here's a couple more examples I want you to see if you can take a guess on again and see if you can correctly figure out which of these are vectors and which of these are scalars. Take a guess, go. All right, here we go. Let's find out the answers. Time is something we'll be using a lot in physics. And time, we think of it as not really moving up, down, left, right. We do think of it as moving forward, but we don't really think about going back in time. So it is a scalar. So like 7 seconds would be a nice example of time as a scalar. Let's see. Force, on the other hand, has direction. So if I apply a force or if I push something, I'm like pushing something forward or backward or to the right or to the left. So force is a vector. And something we'll talk about more later is how incredibly important and amazing Isaac Newton was as a physicist. But in honor of Isaac Newton, we named the units of force after him. So let's say you push something with a force of 15 newtons. Let's say you push it to the right. Well, again, instead of saying 15 newtons right, let's call that positive 15 newtons. So we could rewrite that as positive 15 newtons. So that shows us the direction and the magnitude. What about area and volume, like volume of a shape? Those would both be scalars because area doesn't really like have a direction, and volume also doesn't as well. So area, maybe we're talking about the square footage of the floor, maybe like 10 square feet or 10 feet squared. That is area. And volume also does not have direction. It's also a scalar. So maybe like this room is really large. So maybe this is like, I don't know, how about 300 cubic feet, sorry, feet cubed, cubic feet. And then finally, acceleration is also a vector. So acceleration, which is something we will be talking about a lot this year, is also a vector. So let's say maybe your car would accelerate at like say 3 meters per second squared. Let's say that it accelerated backwards. Let's say you put it in reverse. You were reversing. So that we would call maybe -3 meters per second squared. And there's our direction. Cool. Now, this is a good intro, but let's consider an example with vectors and scalars. And this you can find at the bottom of your target sheet. So let me project that, hopefully, like so. There it is. And let's consider this example. So let's say that we've got a rope that is being pulled to the right with 500 newtons of force and to the left with 3 100 newtons of force, so 3 people. How would we add this up? Well, when you add up vectors, the sum of those vectors is called the resultant. So the sum of vectors is called the resultant. And there's 2 ways to find the resultant. There's 2 ways to add up vectors. We can add vectors up mathematically, or we can add vectors up visually, okay? And mathematically is kind of with those positives and negatives, and visually is with something called the tip-to-tail method. So let's take a look at both these examples. In this case, we're going to think about the rope. So let's say that this rope is being pulled, let's say it's being pulled to the right with 500 newtons of force, and let's say it's being pulled to the left with 100 newtons, and 100 newtons, and 100 newtons. Okay. If I really want to be accurate, which I probably should, I should draw these a little more to scale. So this line should be 5 times the length of all of those guys. So maybe something like that, or possibly even longer. Mathematically, here's how we do it. To find the resultant, what we're going to do is we're going to add these all up. And it's going to be equal to this plus this plus this plus that. Well, we got to include those positive or negative signs because these are vectors. So the way we'd add it all up is we'd say negative 100 newtons plus negative 100 newtons plus negative 100 newtons plus positive 500 newtons is our resultant. Add that all up, and what we discover is our resultant is positive 200 newtons, or 200 newtons to the right. So that's how you would add vectors to find the resultant mathematically. But what about visually? Here's how we find it visually. The tip-to-tail method. Basically, really quickly, the way we do that is you're going to draw each of these vectors successively, one after the other, and wherever you leave off with one, at that tip, you're going to start to draw the next one, the tail of the next one. So where you leave off with one, you're going to start the next one, tip to tail. So we'll start with this one, the longest one. I think that's easiest. You'll get the same answer no matter what you start with. So here's our 500 Newton one, and this is where we leave off. So at that tip, we're now going to draw the tail of this one. So it's going to come back 100 newtons like this. And where we leave off there, we're going to draw the next one. So that one is going to come to the left another 100 newtons. And then where we leave off with that one, we'll draw the last one. And it's going to go like this, another 100 newtons to the left. And so the resultant is the line from our start to our end of this whole chain of vectors. So the resultant is that. That's our resultant right there. And if we think about that, we can see what that adds up to. Well, this is positive 500, this is negative 100, this is negative 100, and negative 100. So we can see what this resultant is positive 200 newtons is our resultant. So there you have it, folks, our very first flip video. I hope this made sense to you. I hope it went well. Please ask me questions tomorrow. Shoot me an email tonight if you have any questions. And thanks for watching. See you later. Bye.